Here's 9-2, day 2. Focus is still on proportions. This is going to be our first look at a two-sided. Obviously, this slide has the context of the problem. Benford's law is interesting. Feel free to look it up a little bit. It's kind of a it's well known enough that you just Google it, it'll come up. It's interesting. Basically, that and it's not just limited to economics, that there's all kind of numerical patterns that show up in the world around us. But one of them is an economic one that, if you're looking at a company's expenses, that all leading digits don't show up equally. Okay, a lot of factors that would go into that, but typically speaking, the leading digit of a 1, which is more common than the other 9 digits, if we're including 0, it shows up about 30%. Okay, 30.1% is technically what Benford's law states. Okay, so we're doing basically an audit of a company's expenses and deciding if we should look further if there's any suspicion in their record keeping of their expenses. Which leads to this. Okay, our state step says that HO, again, this is a proportion, so we got P is 0.301, and then notice HA says that P is not 0.301. Could be too high, could be too low. Right? This is our first look at a two-sided. P is the true proportion of expenses that begin with the digit of 1. This will be a 1 proportion z-test. At alpha 0.05. Random we have an SRS of 300, we'll call them expenses. This is likely a company that has thousands and thousands, if not tens or hundreds of thousands of expenses. We just randomly selected 300. Okay. For normal, there's N times P. That is at least 10. It's okay that these are decimals. We haven't seen that before again, but that is okay. They're both at least 10, so we can use a normal approximation. Now we get down to our do step. I didn't reference it on the other slide, but it said of those 300 expenses, 68 started with a 1. So that's where I'm getting 0.2267. Remember this part, I'm just kind of pretending that I'm going to calculate this. That number I would get from the test feature on the calculator. And then right underneath it, my 1 proportion z-test would give me a p-value, which would say 0.005. Since the p-value is less than 0.05, we would reject HO and say that there is convincing evidence that the proportion of expenses that have a first digit of 1 is not 0.301. Okay? If this was like a test question, that next line that they should be investigated more closely, that doesn't need to be there. You could stop, technically, right there would be a good stopping point for a sufficient conclusion. Now something gets kind of interesting here with a two-sided test, and that's kind of what I'm after here, is to show you. You could take a confidence interval approach, but I want to show you kind of how they line up, right? Because both cases really offer two different conclusions. Okay. On the significance test, it's fail to reject or reject, and with a confidence interval, which we'll see on this slide, basically we'll construct the interval, and then what we could check for is the parameter value in the interval or not. That would it follows the same outcomes as the test. Okay. So I'm going to construct a confidence interval. This I'm going to go through quickly. We already technically did this condition. Now notice in the state, this is kind of a review of confidence intervals, no HO, no HA. Right? I'm not hypothesizing as to what P is. I'm looking to see if it's close to 0.301, but I'm not making the assumption that it is. That actually shows up in the normal condition right here. Here I don't use P. Essentially there I'm using the data that was collected, right? That's a big difference because in a significance test we're assuming HO is true. So when we calculated that p-value on the slide before, we were assuming that the bank was not committing any fraud and that their expenses had a leading digit of a 1, 30.1% of the time. Okay. Here, this is different. Notice in the state step, I never made that assumption that P is 0.301. Here's our do step. Plus or minus 95% confidence. Again, notice here, basically I'm using p hat instead of p, but with a confidence interval, again, you do that because I didn't make that assumption that p was 0.301. Here we choose a 1 proportion z interval, and we would end up with that we are 95% confident that the true proportion of expenses that begin with a 1 at this company is between 0.17 and 0.27. Okay? Now, what I want to talk about here is the connection between the two. Okay? On the slide before, we rejected HO because we were convinced P isn't 0.301. That's consistent with this interval. Look at what number isn't contained in the interval. Okay, this gives us kind of this interval of possibilities, like all the different values we think that P could be. And again, we're up at 95% confidence. 0.301 isn't one of them, right? It looks like the true proportion is probably less than that. It only goes up to 0.27, okay? So if you do this interval approach, again, this is just a two-sided test type of thing. If you go with the confidence interval, okay, rejecting HO is the same as seeing that the parameter isn't in the interval. Okay, those two would go together. And the opposite would be true as well. You fail to reject, you're going to see the parameter in your interval. Now here's the context. I'm going to do another two-sided. I'll summarize it for you, but if you want more details, obviously read it through. There's a parameter that's reported that 75% of restaurant employees say that stress at work negatively impacts their life. Okay? So an owner of a restaurant or a chain of restaurants, it doesn't really say, wants to check to see at their particular restaurants, is it different? And we're not giving any indication if we think it's more or less, just is it different? Okay? Did an SRS of 100. There's your state step. HA is that P is 0.75, so we'll assume that the proportion is the same for our restaurant as it is for the national proportion, okay? And then we'll have to be convinced if it's different. So this is the fourth one we've done the last couple of lessons. If you want, I'm going to obviously work through the whole thing. But if you had wanted to, you could certainly, for the plan and the do, you could hit pause and just see, could you just hammer out the rest of the test yourself and then just resume and see how you did. We have an SRS of 100 employees. Okay. $75 and $25 are greater than 10. Okay, notice I use the parameter values because up at the top here I've got HO, and at this point, right, it seems like it seems like a little thing, but it comes up in a lot of different ways. That at this point in our test, we are assuming that the proportion for our restaurant is 0.75. Okay, we're assuming it's 0.75. We'll have to, if it's different, we'll have to be convinced and reject HO. P hat was 0.68. P was 0.75. That number down at the bottom will tell us how repeated samples of 100 would vary. We get negative 1.62. That's obviously coming from our calculator. And .106. P-value is greater. We fail to reject HO. Okay? We don't have convincing evidence that our proportion of employees that say stress is negatively affecting their personal life, that it's different. We don't have any evidence at our restaurant that it's different from the national proportion. Okay? We saw from our sample of 100 it was a little bit lower, but it was not enough. Again, to say that it's significant and that it's convincing, we make the jump from the sample to the whole population and say, hey, we think this number is actually lower for everybody. And our test didn't give enough evidence to say that. Now down below here, I'll go take a look at some mini-tab. Okay. I'm not going to do the 4-step for the confidence interval because you saw how that would look on the one before. But look here. We recognize all these numbers. There's what we call X, 68. There's N. 0.68 was P at. And oh, here we go. Right, those numbers should look really familiar. We got those. There is our confidence interval. If we had constructed one, 95% confident. Okay. Is the value of 0.75 included in your interval? Okay. Yes, it is. It goes down to 0.58 and up to 0.77. Okay? That tells us that 0.75 is a possible parameter value. Okay? So as far as a conclusion, if you were to do a confidence interval for a significance test, which you could if it's two-sided, I could say that means fail to reject HO. Now, if we were to fail to reject, here's what we would say. It's the same thing we said on the slide before. If we fail to reject, we say we do not have convincing evidence of HA. When I say true proportion, I mean the proportion for our restaurant, right? That's where we took our data. But we don't have convincing evidence that the true proportion is different which in other words is saying that, we think P possibly could be 0.75. Okay, if we had rejected HO, we're saying that we're convinced that it's not. That didn't happen. Okay, we're not convinced. We think it still could be. Okay, so that's a big thing. You could see some problems come up now with a two-sided test that says, let's do a confidence interval approach. What I would expect you to recognize is the parameter in your interval is like failing to reject. That's what we're seeing on this example. If the parameter is not in the interval, that would be the case where you would reject.